Welcome to CoinShares interview. AI, blockchain, decentralized computing, and of course, DePIN. Today, we are meeting with the co-founder of one of the hottest topics of the year, Ala Shaabana from Bittensor. Thank you, Ala, for being with us today. So you're co-founder of Bittensor. Before diving into what Bittensor is, I would like to know more about your own background.
Yeah, so thanks for having me. So I finished my PhD in applied computing back in 2017. And a lot of my background is actually very academic, not in crypto. So a lot of it has been on how to shrink AI models down to very small circuit boards and applying those to the human body, seeing how we do. After that, I joined VMware, worked there for a while on distributed compute, which was not quite distributed AI, but it's at the same time solving problems using AI that have to do with distributed computation. And then I moved over to Instacart for a little bit, and that's when I started working on Bittensor as well as a part-time thing, and it became a full-time job after that.
So what brought you to digital assets? What picked up your interest?
Actually, it was a very difficult problem that I was solving at the time. Myself and Jake were working on the problem of, can models share knowledge? Can they share information together? And if they do, what does that look like? And at the time, we had created like a very basic example end-to-end where models were learning from each other and they're kind of like learning. But the question we often got was, who cares? How does this make money? Why does anybody matter? Why is anybody incentivized? There were other projects that were trying to do similar, not a similar problem, but a similar approach to different problems, like Folding at Home from Berkeley and SETI at Home, which was the search for extraterrestrial intelligence. They were doing it as a very similar way. It was distributed, anybody can run their software, but there was no incentive. So those projects ultimately failed because they were not incentivized correctly. And so we learned that we needed to align incentives correctly in order to have people actually run these models and we can advance the network. And that's when we ran, basically, blockchain made the most sense. But the tricky part was to make sure that it actually ties directly to the value of tau. Any intelligence produced is tied directly to the value of tau. And to do that, it had to be a fair launch, just like Bitcoin. And effectively, that's where we started.
So pardon my ignorance, but I always thought that, blockchain and AI was mostly a gimmick. So why, according to you, it's a perfect match?
We got the exact same thing the first time. We had a few people laugh us out of the room. The thing is that AI has a problem of verification, and blockchains are very good at verification. So in this sense, they sort of marry well together. If you take, for example, there's actually quite a few projects today that are working on the same problem. They're trying to verify the proof of work done by AI on different GPUs. So, and you're seeing that they're not relying on OpenAI or on Google or on Amazon or whatever, because those companies are losing trust quickly. And sort of this trustless, permissionless environments are gaining traction because you have a lot more control as a result. So in that way, I think blockchain AI is sort of the use case we've been waiting for a very long time.
Would it be okay and fine if I defined Bittensor as a brain with a neuronal network?
You can think of it that way. You can also think of it as almost like a city as well. Almost like you can even think of it as the World Wide Web, where there are certain neighborhoods we call subnets. These neighborhoods solve different problems, kind of like a brain, right? Brain has different areas of the brain that solve different problems, things for balance, things for cognition, things for creative thinking, etc. Sort of similar in that way, in that parts of Bittensor are dealing with storage, parts are dealing with incentivized problems, things like incentivized object creation, things like incentivized defect detections, incentivized network training, incentivized inference. It depends on how you want to look at it, but really the brain analogy works, the city analogy works, as long as you know that there are sectors of it that are solving very different problems and incentivized very differently.
Where does the demand come from? Is it coming from corporations, from retail audience, retail users? Who is using Bittensor?
We're seeing a combination of things. There are corporations that are using it for their own uses. So an easy example is a company called 404. What they are doing is they are generating 3D objects on Bittensor to be used in video games. So companies like Unity are actually partnering with them to actually pull this information out and be able to pull this 3D objects out and use them in their video games that are generated on Bittensor. Another one would be, easy one is research. So the original vision of Bittensor is now coming back. The decentralized training of AI models, right? Which is actually even getting traction with Web2 AI researchers. Even seeing people at DeepMind, they're actually starting to say, decentralized training has a lot more value because, obviously there's cost analysis as well, but also you get more resilient models. You don't end up with narrow specialists, you end up with very resilient generalists. And it's becoming more and more accepted in the circles, and that's sort of where people are tackling it. Finally, there's also institutional investors. There's quite a few who are speculating on the subnet, the Bittensor subnets, sort of speculating they're going to gain value over time. And then finally, you've also got the individuals who are really typically miners, people who are mining on the system, and they're effectively generating intelligence and solving different problems so they can kind of earn tau as a result.
I'm pretty sure that to you it's obvious, but I would like you to explain that to us. Why was it important to have a token in this network?
Incentive, right? As we were mentioning earlier, there are other projects that have tried to do the same thing, not the same problem, but sort of to spread the problem across different users and different computes to actually try and come to a solution. I think the easiest example is folding at home. Back in 2007, 2008, everyone had a PlayStation 3. So the idea was it would use your PlayStation 3 when you're not using it to solve their problem. But the issue was that everyone was solving the same problem and it was a race between everybody and you earned nothing. So projects failed. So really by aligning incentive for everybody and getting them to a point where, in a sense, everyone has the same opportunity to earn on their work, much better than, say, for example, working for Google. We found great success in that.
You gained like a lot of traction in the past few months. How do you explain this growth?
I think it's a lot of different factors happening at the same time. I think it was about a year and a half ago, actually a little more than that. It was the drama with OpenAI, where Sam Altman was leaving. Then he's like, no, I'm not going to leave. I'm going to stay. It really highlighted to people just how centralized AI can be controlled by a select few people. The most interesting part is that there was a verse in their bylaws that said their board of directors has the right to control whatever AGI does if they develop AGI. And for people who don't know, AGI is artificial general intelligence, sort of the holy grail. If they come up with something that is conscious, then 6 people can decide what to do with it. It's ridiculous. And so people started turning to other alternatives. What is a better way to do this? And they found projects like us, which are basically saying that AI is open to everyone. We're incentivizing open source development of AI, which is a very important piece where everyone can see what this AI is doing and how it's being built and what the code looks like, as opposed to closed source like ChatGPT or Gemini or whatever else is out there. And at the same time, they're finding that we are finding there's great traction. And so the project is developing quickly. Ro's releasing very fast. And I think as Con said yesterday, it's gotten to the point where me and him don't do that much anymore. All of our work is in the protocol or maybe in building tooling, but not in developing subnets. Subnets are moving faster than him and I can ever move. And so in that way, some much, much smarter people than us have actually started building on top of the system and creating some very compelling products. And I think that's sort of the last big factor that started moving things quickly.
Again, maybe I'm mistaken, but I often hear about AI is getting to a peak in terms of LLM. Would you say that decentralized AI is a way to overcome this kind of limit?
Potentially, yes. I'm sure you've heard of Moore's Law, and that's effectively just how many transistors we can fit on a microchip. And we're far past that at this point. It's not even relevant anymore. But what's becoming now is that sort of this decentralized access to GPUs is becoming more and more pervasive in our environment. Same thing applies for AI. LLMs have gone way past the point where it can fit them on a small computer. Now you need massive compute to actually run all these massive systems. To train them, to inference them, you would need sort of when I say OpenAI level of funding. What these subnets do, these decentralized training, decentralized inference subnets are sort of, instead of speaking to one LLM now, you're speaking to many. And the validators on the system are picking the best answer for you. So instead of one ChatGPT, you're speaking to a room of ChatGPTs, and there's one smart one that's picking the best one out of you. That gives you not only resilience in your responses, it also gives you more specific responses to your queries, but also gives you a lot more generalized responses as well that are able to sort of answer all the nuances that you might have in your question. Whereas you wouldn't really maybe get that with other systems. At the same time, with decentralized training, is that it was sort of created a point where we can blow past the limitations of hardware that people can have, and we can potentially even hit trillion parameter models very easily. It wouldn't be a big deal anymore. That's sort of the pie in the sky.
How do you foresee the future of Bittensor yourself?
I definitely see it as sort of becoming equivalent of TCP/IP for the world. For those who don't know, TCP/IP sort of runs the entire world. It runs all of the internet today, right? And not many people know about it, but it runs everything. Nothing works without it. I can see it sort of being the underlying layer similarly underneath all of these AI models, right? And it just becomes to a point where training by yourself, if you're a smaller company or anything, doesn't really make sense anymore. You should probably deploy it on a subnet and build an environment where it can actually grow in there, in that sense. So I think sort of it becoming part of every conversation, whether it's a VC, whether it's a builder, at the same time sort of becoming so pervasive that it underlies most of AI development. That's sort of the goal, and that's what I'm seeing happening in the next few years.
So would you say that we are just at the beginning of decentralized AI?
Fairly so. We're very, very early. We coined the term crypto AI, right? We're the first ones there. There's quite a few out there now, you're seeing all these valuations that are being raised, hundreds of millions of dollars towards problems that we've already solved that we're already solving ourselves. And so that tells you that A, we're early, B, the market's still finding out just how valuable these things are, and C, it's sort of the tidal wave is coming. We're at the very front of it.
Thank you, Ala.
Thank you so much. Appreciate it.